All right, our next item is going to be to look at factoring trinomials. Okay, so when we have three terms. In order to factor trinomials, it's important to go back to a previous unit when we multiplied polynomials together, multiplying binomials specifically together. So as a quick warm-up, let's take a look at multiplying these binomials together using the area model, because that's the way that we're going to factor trinomials today, is we're going to use that exact same trinomial or area model process. So let's start with number one. We're going to take x minus 2 and multiply by x minus 4. So with our area model, we can take the x minus 2 and put it down the side, and we can take the x minus 4 and put it across the top. Okay, so we have the x in the first box, or next to the first box, negative 2 by the bottom row, x on the first column, negative 4 on the last column. So with our multiplication problem, we would multiply length times width of each box to get an area of each individual box. So x times x is x squared. In the next box, upper right, x times negative 4 is negative 4x. In the bottom left, negative 2 times x is negative 2x. And the last box in the bottom right is negative 2 times negative 4, which is positive 8. So when we put that all together, including combining the like terms, we'll get x squared minus 6x when I combine like terms, and then plus 8. If I do the same thing for example number 2, we have x minus 3 down the side, and then we have x plus 5 across the top. We multiply to get the individual areas and combine like terms when we write our answer. So in this one, we'll get x squared from the first box. We add together the like terms. 5x plus negative 3x is positive 2x, and the minus 15 from the last box. So what I want to do is I want to focus on the last part. Okay, in number 1, we got a positive number. And then number 2, we got a negative number. So I want you to think about, how did we get that positive 8 in number 1? Why was it positive instead of negative? Well, it was really the result of multiplying a negative number times a negative number to get a positive number. I guess the other way you could do that is if we had positive times a positive equals a positive. But that would have been a different example. Number 2, if we look at that same idea, how did we get a negative number in that last box? Well, we multiplied a positive times a negative to get a negative number. And notice that's what we have inside our parentheses, a positive and a negative. But in the first example, we had a negative and a negative, which multiplied together to be a positive at the end. So those signs in the parentheses, those signs in the binomial factors, are actually going to help us determine the sign of that last number in the final box. In other words, that constant term in our answer can be determined just by looking at those signs. Now, there is also another way to look at how to tell if this first sign is going to be positive or negative, but we'll come to that later. Let's take a look at factoring trinomials. Okay, so to start with, just a reminder that when you multiply, you're putting the factors together. You're multiplying a factor times a factor to become this product. Whether it's 5 times 4 is 20, or x plus 2 times x plus 5 is x squared plus 7x plus 10. Either way, we have to keep in mind that we're multiplying two factors together to get a product. So when we factor an expression like that, you could factor 20 as 2 times 10, or 5 times 4, or 1 times 20. Or you can factor a polynomial like this, a trinomial, since there's 3 terms, by trying to figure out what multiplies together to give you x squared plus 7x plus 10. And that's going to be the result of multiplying two binomials together. Notice we have addition, or it could be subtraction, in each one of the parentheses. That's important because that's what we're going to try to do today. We're going to start with a trinomial. We're going to try to figure out what are these two binomials. And I like to look at this kind of like a puzzle. It's our area model, but it really is just a puzzle. We are going to take our trinomial, x squared plus 15x plus 44, And if you remember how we added in the warm-up, or I should say how we multiplied binomials in the warm-up, we have to take something times something else is going to equal this x squared plus 15x plus 44. Now this represents the area, this trinomial. So in my 4 boxes, I know that the x squared is going to go in the first box. I know that these 2 boxes have to add up to 15x. I just don't know how it's split up yet. And I know that the last box has to be 44 because those are my 3 terms right here. So the real task is going to be starting with what we know has to be true, that the first box is x squared, the last box is 44, and using that to try to figure out the rest of the puzzle. So if we were to factor and think about, well, what times what equals x squared, really the only option is x times x. So that's a must. We know that that has to be true. The rest of it is, well, what are my factors of 44? So what times what is going to equal 44? And there's actually a lot of different numbers that we could use because there are multiple factor pairs of 44. If I were to make that list, do 1 times 44, 2 times, well, let's see, 44 divided by 2 is 22. 44 divided by 3 does not work. That's a decimal. So 4 times 11 is 44. I can't divide 44 by 5. I can't divide it by 6 either. And I guess that's as far as I need to go because 6 times 7 is 42. So anyway, there's our factor pairs. So those are the only possible numbers that we could place above the last column and by the next row, or the final row. So we have to try to figure out which numbers are the correct numbers. Now, if you think about our like terms here, they have to add up to 15x. So this is the puzzle. I have to pick 2 numbers that multiply up to 44. In other words, they're in our list over here. But the same 2 numbers have to add up to that coefficient. They have to add up to 15. You recognize which factor pair will add up to 15? It's not 1 and 44, because that adds up to 45. 2 plus 22, well, that adds up to 24. It has to be 4 and 11. So 4 times 11 is 44. Okay, so that part of my puzzle is okay. And now when I fill in the rest of it, I get 4x in that box, 4 times x. And down in the lower left-hand corner, 11 times x is 11x. And if I add my like terms together, 11x plus the 4x is 15x. So inside I have the correct area of x squared plus 15x plus 44. So I have to think about, what did I multiply together to get x squared plus 15x plus 44? Well, on the left-hand side, I had x and 11. So that's x plus 11 as one of my binomial factors. And then across the top, I had x plus 4. That's my other binomial factor. So instead of starting with the length and the width of the rectangle and finding the area, we're actually starting with the area and trying to figure out the puzzle so that we could figure out the length and the width. That's factoring. Finding what multiplies together to give us our product from the beginning. Here's another one. We've got x squared minus 9x plus 14. And if we stick to our process that we did last time, we know kind of how this is going to fit inside as the area. The x squared goes in the first box. I have to figure out how it's going to give me negative 9x when I add the like terms together. But I know that the last box has to be positive 14. So that means I want to try to figure out what multiplies up to 14. Because I know it's x times x equals x squared. But there's more than one way to multiply 2 numbers together and get 14. It could be 1 times 14 or 2 times 7. And I guess that's about it. So let's see, what is it? Well, is it 1 and 14? Let's check. 1 times x gives me 1x. 14 times x gives me 14x. When I add those together, I get 15x. All right, so that's not right. It's not 1 and 14. Cross that out. Oh, then it must be 2 and 7. So let's change that. 2, 7. So 2 times x, 7 times x, add together to give me 9x. Okay, now the only problem is they're supposed to add up to negative 9x, not positive 9x. So how do I add two numbers and get a negative value, a negative overall value? Well, I guess it's kind of telling me that I can't start with two positive numbers. I have to start with two negative numbers. They're still going to multiply up to 14. A negative times a negative equals a positive 14. But now we have two numbers that will add up to this negative 9 that we need it to. So let's go back. Let's reset our area model using -2 and -7 and see if that works out. So in the top right corner, I'm going to take -2 times x. In the bottom left-hand corner, I should be multiplying -7 times x. And when I combine my like terms, that would equal -9x altogether. So we have x squared minus 9x plus 14. That is the total area. That's the correct area. So how did we get that? It's when we took x minus 7 as one factor and then x minus 2 as the other factor. So x minus 7 times x minus 2 is my solution. That's my factored form. All right, here in number 3, it's a little bit different this time. Same setup, same type of problem. We're starting with the trinomial and using the area model to factor. But you might notice that we have a minus 20 at the end. So it was x squared in the first box. Somehow these two like terms have to add up to 1x. Not quite sure how that's going to work just yet. And then this minus 20 is going to have to go in the last box. On the first two examples, that was a positive number, but this time it's a negative number. So in terms of factoring, I know it has to be an x times x to give me the x squared in the first box. And now I want to try to find what two numbers will multiply up to -20. Well, think about it. How do I multiply two numbers together and get a negative product? The only way that's going to happen is if one number is positive and one number is negative. So I'm going to start by, well, let's just list the factor pairs of 20. So 1 times 20, 2 times 10, 3 does not go into 20 evenly, so 4 times 5. Okay, and then we're back to like 5 times 4, 10 times 2, and 20 times 1. All right, so that's how I can get 20, but the only way I get -20 is if either that side's negative, or let me rewrite all of these, or it's the other side that's negative. Okay, so those are my factor pairs of -20 that would be possible. Now, if you've been paying attention on the first two, you might also remember that using those same coefficients, my like terms, which will have those coefficients, have to add up to this coefficient of the middle term. It has to add up to 1. So which pair of numbers from my factor pairs of -20 will actually add up to +1? Well, it's not going to be -1 and 20. It's not going to be -2 and 10. It definitely is going to be -4 and 5, because that's the only pair of numbers that will multiply up to -20, but also add up to that middle coefficient of 1. And the other ones don't work either. Even this last one, 4 and -5, that's going to add up to -1, not +1. So that gives me a clue. That gives me the numbers that I want to use. Let me clear this off here. We had x squared in the first box, -20 in the last box. We are going to use a -4 and a +5 to get my product of -20. And then we check the actual area with those like terms box. -4 times 5, +5, -4 times x, and 5 times x. And when I combine like terms, that's going to add up to positive 1x, since 5 minus 4 is 1. So now I have the correct area, so it's modeling the actual problem. So now I can look at it as, all right, well, what did I multiply to get that? One of my factors was x plus 5, so I put that in parentheses. The other factor was x minus 4. Now, it would not make a difference if I put the x minus 4 first. I just happened to write it that way. All right, last problem. I would encourage you at this time to maybe try this one on your own to see how you're doing before getting into that recommended homework. So pause the video, try it. When you're ready, click play to see how you did. So I'm going to start filling in what I know has to be true, right? X squared goes in the first box, negative 16 goes in the last box. And now I have to figure out how do I get negative 6x when I add those two like terms together. I don't know what those terms are going to be at this point. So then I factor those perfect squares, right? Or the first term, last term. So the x squared is going to be the result of x times x. That's the only way it's going to happen. The negative 16, however, that has multiple different factor pairs. So negative 16. So let's see, 1 times 16, 2 times 8, and 4 times 4 equals 16. But because I'm supposed to multiply two numbers together and get a negative answer, either the smaller number is negative or the bigger number is negative. And I guess really this negative 4 times positive 4 is what I already have up above. That one's kind of the same thing. So I have to check, of these 5 combinations, which combination of numbers has a sum of negative 6? In other words, which ones will add up to a negative 6? Well, the only way it adds up to a negative is if the bigger number is negative, so it's not those. And then which one would add up to negative 6? It's 2 and negative 8. 2 times negative 8 is negative 16, but 2 plus negative 8 is negative 6. That's the combination that we need. So let's put our numbers on the side in either order, doesn't matter, and let's check it. 2 times x is 2x. Negative 8 times x is negative 8x. And when I combine my like terms, I get negative 6x like I need it. So I have the correct area. On the side, I have x minus 8, so that's one of my binomial factors. Across the top, I have an x plus 2 more. Remember, if it's positive, it's addition. So my correct factored form is x minus 8 times x plus 2.